So this is the last video of this particular series. There was 5 videos that go together. What it was one module divided into 5. There are a lot more videos coming, just so you know. I'm going to be slowing down because I'll be working on a novel and a screenplay for a project called Script Frenzy, which starts April 1st. So I have to get that done before I can get back to the Wow Seti videos. So they're going to be a little more sporadic. They're not going to be as often as you're used to. But if you check back each week, I'll try to do at least 1 video per week so you have something to watch, okay? So this is part 174, line 18A, a3z5b, uniform convergence tetrahedra isomer hydrocarbon cracking 5G Wow Seti. So there's the alien radio signal there, and this is to continuity uniform limit theorem. The funny thing was when I first started this, I had this one picture, that's it. And I read through it and I just deleted all the extra stuff because I didn't understand anything. And I was going to just like delete it all and just let it go because I figured it didn't have anything important. And then I started Googling each of the different words, and then I came up with some really cool stuff. So you'll be surprised with what comes up in this one. So March 22nd, so counterexample to a strengthening of the uniform convergence theorem in which pointwise convergence rather than uniform convergence is assumed. So it shows sin 100x and then sin x. So again, we got something showing an increase of something, okay? So March 22nd, 2012, my thoughts. I'm not sure what this is for, so I'll just go on to the next video, which is what I didn't do because I started Googling more words, okay? So this was what I wrote. I was going to give up, and then I Googled another few words and found what I was looking for. There you go. So I did a Google search on space marching to see what it was. So space marching comes up. So what I usually do is I take the different words in this here and I just start Googling each of the words to see what stands out to me. And this word came out, space marching. So generalized spatial discretization techniques for space marching algorithms. So this is a PDF file that came up from McGrory, William Dandridge. It's a thesis from Virginia Polytechnic Institute and State University Blacksburg. So it says 2 unique spatial discretizations using generalized indexing strategies suitable for use with space marching algorithms are presented for the numerical solution of the equations of fluid dynamics. So we're talking about fluids here. So you want to think of liquid argon gas. You want to think of the formulas that we've looked at from line 17 and lines 18. And so far, there's going to be more. So you're going to apply this algorithm to it. Okay, space marching algorithms. Okay, so both discretions attempt to improve geometric flexibility as compared to structured indexing strategies and were formulated while considering the current and future availability of unstructured grid generation techniques. The first discretization uses a generalized indexing strategy using triangular elements in the 2 dimensions normal to the streamwise direction. The second discretization subdivides the domain into a collection of computational blocks. Each block has inflow and outflow boundaries suitable for space marching. A completely generalized indexing strategy using tetrahedra is used within each computational block. The solution to flow in each block is found independently in a fashion similar to the cross-flow planes of a structured discretization. Numerical algorithms were developed for the solution of the governing equations on each of the 2 proposed discretizations. So the keywords for this. So I didn't understand what it was really talking about. And then I saw the keywords and I thought, okay, I'm going to put it in the video because it talks about algorithms, Euler equations of motion, flow distribution, grid generation, mathematics, spatial marching, computational fluid dynamics, and computational grids and crossflow. All these keywords came up in the Wow Seti videos. So I figure whatever this is, you can use it. So the ADS is operated by the Smithsonian Astrophysical Observatory under NASA grant NNX09AB39G. And that's at adsabs.harvard.edu. So we're going to Google tetrahedra to see what it is. And this comes up. The arrangement of atoms in space, 1874 to 77. So this is a really old document from the 1800s by J.H. Van 't Hoff. It's translated into German by D.F. Herman, 1877, and it was at the www.chem.yale.edu site. So here's some drawings for you to look at. I have no idea what they are. You guys do. Something about mirroring, something else. Van 't Hoff suggested two ways of using tetrahedra as models for the carbon atom. Sorry if I'm saying the word wrong. Number one, for drawings, one could consider the carbon atom in the center of the tetrahedron with labeled or colored verticals, denoting the bonded atoms or groups. Thus, enough ethane molecule with 6 substituents and free rotation about the central CC bond could be drawn as follows. So, the key words here is we're talking about molecules, a carbon atom, that's come up before, and then we have free rotation. Now, we want this UFO to rotate, right? So, note that Van 't Hoff, like Pantano, draws ellipsed rather than staggered conformations. Again, these are keywords from the thing. Double bonds could be shown by tetrahedra sharing of 2 verticals. Here are his drawings of the 2 diacids, fumaric and malic acids, known at the time, from replacing 1 H on each carbon of ethylene with COOH. Now we call these 2 isomers trans and cis, or E and Z. R in the figure means the vertex should be colored red. Now, keywords here is isomers. We've had that come up. Carbon, ethylene, that's come up before. Fumaric and malic acids, those have come up before. E and Z, E for Euler, Z for Z bosons. So, you know, you can make a formula out of that. And this is what their diagrams look like. There you go. So this is triple bonds which share these 3 vertices. Okay. And there's another drawing here for you to look at. So in the case of a symmetrical formula with 2 asymmetrical carbon atoms, there are only 3 isomers for which the rotary power would be. So this will help you develop some form of rotary power, which is what we need for the UFO, okay? So there's your formula that they have. So in the second case, optical rotation disappears completely, although it involves an asymmetric carbon atom. We would like to name as the neutral case a situation where rotary power due to one or several asymmetrical carbon atoms is cancelled by the equal and opposite rotary power of another one, or several asymmetrical carbon atoms, a case that would only occur when the formula is symmetrical. So when it says that, I was thinking that, okay, so that shows you how to rotate the device, and then also shows you how to stop the rotation. Okay. Tartaric acid offers a perfect example for the statement. The formula for this substance is symmetrical and includes 2 asymmetric carbon atoms. So here's the formula. This is their formula, not mine, okay? In fact, 3 isomers are known for this formula: right and left-handed tartaric acid with equal and opposite rotary power, and optically inactive tartaric acid. I feel like I'm repeating myself here. The optical inactive tartaric acid had already been named meso-tartaric acid, and we have now generalized by using the name meso to designate all compounds in Van 't Hoff's neutral case. The name meso means between. For example, Mesopotamia is the land between 2 rivers, the Tigris and the Euphrates. The optical rotation of meso-tartaric acid is certainly between those of D and L tartaric acids. I don't know if that's an L or an I, I'm not sure. Note that rotary power refers to the ability to rotate the plane of polarized light, and that Van 't Hoff indicates asymmetric carbons with italics. Again, with the this could also not only go for the ship, but it could also go, it says rotate the plane of polarized light. So that's a key word there. And I think I bring it up No, I don't. Okay. So to rotate the plane of polarized light, though, you would use that for your neutrino testing as well. Okay. We'll talk about it later. It does come up how to rotate the plane of light so that you can get your neutrinos to oscillate better. So Van Hoff's neutral case, tartaric acid, again, these are the two words that come out. I do some Googling and I get a chiral molecule is a type of molecule that has a non-superposable mirror image. The feature that is most often the cause of chirality in molecules is the presence of an asymmetric carbon atom. Let's take these paste from things out. So isomerization is the process by which one molecule is transferred into another molecule which has exactly the same atoms, but the atoms are rearranged. I had to put that in here because that kind of explains some things. So in some molecules and under some conditions, isomerization occurs spontaneously. Many isomers are equal or roughly equal in bond energy and so exist in roughly equal amounts provided that they can interconvert relatively freely, that is, the energy barrier between the two isomers is not too high. When the isomerization occurs intramolecularly, it is considered a rearrangement reaction, and that's from Wiki. So isomerizations and hydrocarbon cracking. Again, isomerization and hydrocarbon cracking has come up previously in the Wow Seti lines of video from line 17 to 18. This is usually employed in organic chemistry where fuels such as methane, a straight chain isomer, are heated in the presence of a platinum catalyst. It's funny because pentane comes up, isomer comes up, and platinum beryllium comes up in earlier videos. The resulting mixture of straight and branched chain isomers that have to be separated. An industrial process is also the isomerization of N-butane into isobutane. So it shows pentane to methylbutane to dimethylpropane. There's their formulas. So March 22nd, my thoughts. This is like the neutrinos taking on the characteristics of other particles that they collide with. Perhaps what is happening is this isomerization process. The key word here is carbon cracking. Searching notebook files and I find this. Line 18A3S6C. Agroplast gas plus microwave CnH2 reactor cold plasma Wow Seti. The PDF files on there are old plasma cracking of hydrocarbons, and that's from www.agroplast.no technology. Microwave cold plasma can be used to turn methane into hydrogen gas and solid carbon. Same website. So I'm going to pull the notes and formulas from that video and post it here. You can watch that video to see the rest of the data because I didn't bring everything over. I just brought the keynotes over from that video because it's important. It must mean something if it's coming up again. So March 23rd, 2012. That's when I started adding the word liquid to argon gas, to the liquid argon gas formulas. Okay, so I keep track of that. So anything before that just says argon or argon gas. So data pulled from the video, line 18A3S6C. February 10th, 2012 was when I was working on that particular video. This is my thoughts. Here we find some methods and new inventions that we can use for the muon bombardment frequency plus energy plus accelerate photocatalytic effect. You want to take a laser, add the heat, add the liquid argon gas plus neutrinos and equals your acceleration plasma. You want to take the gas plus cold plasma reactor, add the Vasmir, the neutrinos, the methane cracking plus the carbon nanotubes plus the graphite mirrors plus a space elevator. All these things will go together, I guess. So I separated this particular data into 3 sections so we could look at each set of things in units. So you want to look at line 18A3S6, muon, ox, quark, ammonium, percolate, argon gas, neutrinos, Vasmir rocket, Wow Seti. The next video you want to take a look at is line 18A3S6b, NASA LIDAR 5G laser pulse neutrino propulsion Wow Seti. Then you got line 18A3S6C, Agroplast, Gas Blast, Microwave, CnH2 Reactor, Cold Plasma, Wow Seti. So it's up to those who invented these things to get together, compare notes, and see what you can come up with in relations to the propulsions required for a 5G force UFO engine. Take a look at all the data provided about neutrinos, add the mathematical equations that are mentioned in each video, and put it all together to develop the new alien technology that is required to meet this goal. So you want to take neutrinos, add your gas, add the mathematical functions, plus the calculations, plus the equations, and plus the jet propulsion ideas. So you want to look in line 24, 22, 28. There's all the line numbers you want to take a look at. These ones have not been filmed yet, by the way. They came up because there are keywords on those lenses that I haven't researched yet, okay? So that's where you want to look for this data. And line 13, 18A3z5b, Uniform Convergence Wow Seti. Okay, so these are the tags for this video. They're a little bit different than the other ones. They got a little more stuff added to them. I actually put my formulas and video titles in there. So that's the last part of those 5 little videos for that one line of data. And I have to do more research. I'm not going to have much time this week, so it'll probably be another week or so before I post any more videos, okay? Thanks for watching.